What's up, what's up, what's up, y'all? It's Gradius coming at you live with a video about exponential functions. Let's get it. So, here I have a function, and it's an exponential function because if you notice, I have f of x equals 2 raised to the power of x. So, this is an exponential function as my x value is actually the exponent. Okay, so we're going to make a table first to see what happens, what are the key characteristics of this function, what does it look like, so on and so forth. Okay, so I have these values that we're going to plug in for x, and then we will graph it, see what it looks like. So if I plug in negative 2 for x, I have 2 raised to the power of negative 2, which means it's 1 over 4. Okay, we do need to know our properties of exponents, negative exponent, we flip it, 2 squared is 4. 2 raised to the power of negative 1. Okay, flip it. It's going to be 1 over 2. 2 raised to the power of 0. Anything raised to the power of 0 is 1. 2 to the first power is 2. 2 squared is 4. And 2 to the third power is 8. Okay, so now what we're going to do is we are going to graph these points. So I have negative 2. 1/4 is about right here. We'll just give an estimate. Negative 1 1/2 is about right here. 0 1, 1 2, 2 1 2 3 4, and 3 1 2 3 4 5 6 7 8. So if we look, doesn't increase very much in the beginning, and then it starts to increase a lot. And it'll keep going like that. It'll also keep going this way, like so. So that's what the graph looks like. So now what I would like to do is I want to talk about what are the key characteristics of this graph, what do we notice, so on and so forth. So that's just a nicer looking version of the graph that I just tried to draw. So looking at this, key characteristics. First, we can always talk about domain and range. That has not changed with regards to what domain means and what range means. So if I was looking at the domain and range, the domain is all the possible x values. So if I look, this graph, I can plug in any value for x I want. I can plug in negative numbers, I can plug in positive numbers, and I can go infinite directions. So the domain is just all real numbers. Okay. Now, so our domain is all real numbers. Now let's look at the range though. And this is where it's going to get a little tricky, and we're going to learn this new term asymptote and stuff, because that kind of includes the range as well. So with asymptotes, with range, it's all the possible y values. Well, if we look here, it looks like it's going to go on forever north, so above 0. But I want to know, is it ever going to cross 0 here and get to negative? Is it possible for my y value to be negative? And the quick and short answer is no, it is not. And let's talk about why. If I plug in, no matter what negative number I plug in, let me plug in negative 100, because it's decreasing as we go further negative. If I plug in negative 100, well, that doesn't mean that my y value is going to be negative. That just means it's 1 over 2 to the 100th power. Well, 2 to the 100th power is going to be a really, 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 really large number, but it's not going to be negative. It's still I still have a positive value here. So we're always going to get really, really, really close to 0. This is a really tiny, tiny number. Okay, it's a tiny fraction. So we're always going to get really close to 0, but we're actually never going to get to 0. We're never going to cross 0. So therefore, the range has to be greater than 0. Okay, because we're never going to get to 0. It's going to get close. I can plug in 1 and 2 and negative 1,000, which would be 1 over 2 to the raised to the power of 1,000. That's going to be a tiny number, a tiny fraction, just so microscopic small. But it's still not 0 because I have that 1 in the numerator. So no matter what number we plug in, what x value, we're always going to have something greater than 0. So my range is y is greater than 0. Y-intercept looks like it crosses at 1. Okay, which does make sense. When you plug in 0 for x, you get 1 as your answer. So that makes sense for the most part. Asymptote. So the asymptote, okay, and this is your definition down here. But again, as we talked about how this particular function gets really, 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 really close to 0, but it never quite gets there. Okay, so the asymptote here is 0. Asymptote is a line in which this particular function approaches but never quite reaches it. Okay, so this approaches the x-axis but never quite reaches the x-axis. Well, the equation for the x-axis is y equals 0. Okay, because that's just a horizontal line here on 0, so it has a 0 slope, y-intercept of 0, y equals 0 is the equation of the x-axis. So because the x-axis is an asymptote, it never quite approaches it, but it's going to get closer and closer to it without ever quite getting to it. The asymptote is y equals 0. Okay, these are key characteristics, and these are key characteristics when we're looking at exponential functions. Domain and range, as with any other function we've worked with so far, y-intercept, and then does it have an asymptote, which they will, and then what is the actual equation of the asymptote. Now, I know a lot of you want to ask, is the domain always going to be all real numbers? I don't like to say always, but for the most part, it's going to be all real numbers a lot of the time. Is the range going to be greater than 0? Most of the time, yes. Okay. The y-intercept will definitely be changing, and we'll show what happens and how we do that. So let's look at some other possibilities here. So one thing I want you to get down is this is your formula for exponential functions. Okay, so sometimes you'll have an initial value being multiplied before the exponential function, but you also have what's called a constant ratio. So let's please get this down, because this is the big piece right here. Now we're going to write down some exponential functions from this. Okay. Now, looking at this, a couple things I want to point out here. So this first number right here is what we're multiplying by, and that's also the initial value. It's basically the y-intercept. Okay, so you can put y-intercept right here. The reason why we call it that, let's go back to here. There's no number in front of this, right? But I could, if I really wanted to, I could write it as this. Because isn't 1 times 2 to the power of x the same thing as just 2 to the power of x? So this 1's not written there, but it could be, because it doesn't change the value of anything, and that 1 is my y-intercept here. Okay, so this is really just the y-intercept. It's the initial amount, but also the y-intercept. So that's kind of where we start. Okay, b is the constant ratio. That's pretty much how much it's going to be increasing by, but it's not a constant rate. Okay, it's a constant ratio. So I'll show you what I mean by that. Going back to our last function, I'm going to go back to the initial table. When I say constant ratio, I'm really looking at the constant ratio between these two values. So what's 8 over 4? It's 2. What's 4 over 2? 2. 2 over 1. See what I'm doing here? We're just finding the ratio between our new y values. Okay? And you should get 2 each time, because that is the ratio. And that's, of course, when we're increasing by 1. Okay? So do not just do y divided by x. That would be your ratio. If I just did y divided by x, you're not going to get the same value every time, because it's not a linear function. It's not a proportional relationship. Okay, so for exponential function, we're looking at a constant ratio, but when we're looking at that change in the y's. Okay? All right. Also, this has to be something greater than 0, our initial value. And then, our initial value is not 0, that's all. And our constant ratio is something that's just greater than 0. Okay, so this has to be greater than 0, but also can't be 1, because if b was 1 here, if I had 1 raised to the power of x, well, everything's just going to be 1. So that wouldn't be an exponential function. Okay. That being said, let's see if we can write down exponential functions from a table and from a graph. So from a table, the first thing I want to notice is what's my initial value? What's my y-intercept? Well, when x is 0, my y-intercept is 4. My x is 4. My y is 4 when x is 0. So therefore, my initial value, I know right away, it's f of x is equal to 4 times something. Okay? Now I want to figure out what my constant ratio is. Okay? So how much are we increasing by? Well, I could do 12 divided by 4. I could do 36 divided by 12. I could do 108 divided by 36, and 324 divided by 108. But we do get 3 each time. So 3, whoa, that was wild. 3 raised to the power of x is my constant ratio. There's my exponential function. I'm all done. There's nothing else I need to do. Okay? Now, looking here, I have a graph that I need to write the exponential function for, so we always start with the y-intercept. So my y-intercept is 128. That was easy. 5 f of x equals 128 times. Okay. And then we can multiply that by the ratio. Well, okay, so we have our y values here. So I went from 128 to 164 to 64. Notice how this one's decreasing. It's going the opposite direction. So our initial function we had was going this direction. This one's decreasing. Okay. So that does not mean it's negative. Okay, we said that we want it to be, it needs to be a positive number. Well, let's look at what the ratio is. So if I make a table real quick, if I'm going from 0 to 128, and then I'm going, my next point looks like it's 1 and 64. My ratio is not 128 over 64. Okay, my ratio is 64 over 128. It's also 32 over 64. Then it's, okay, so if I look at 64 over 128, I get 1 over 2. So it's 128 times 1/2 to the power of x. 32 over 64 is 1 over 2. Now some of you are looking at it, well, this one goes from 32 to 8. So 8 over 32 is not 1/2, it's 1/4. But also we skipped a value here. We went from 2 to 4. Okay? And so we need to be cognizant of that. We need to also figure out what the point is in between as well. Okay? And because we went from 2 to 4, we multiplied by 2, so I could end up multiplying by 2 to get to 1/2 still. All right. So here we go. F of x equals 128 times 1/2 to the power of x. So when it's decreasing, some of you might have noticed that then we have a fraction instead. Okay? All right. So go ahead and just try to graph it on your own. Okay, you can graph it by making a table. There's nothing wrong with that. That's pretty much how we have to graph these, okay? Because we're not going, there's no slope here. Okay, and then I want you to see if you can tell me what the domain, the range, the y-intercept, and the asymptote is. Domain, range, y-intercept, and the asymptote. Okay. So, real quick for my table, I'll just go 0 through 4. There's my x values. Don't know why I can't draw on a straight line. My apologies. Yikes. Okay, this is going to be ugly. It's okay. We'll make it work. So if I plug in 0, I have 2 times 5 to the power of 0. Well, that's going to give me 2. We should have known that right away, just based on this is our initial value. It's also our y-intercept. 2 times 1 is 2. That's where we're going to start. But now if I have 2 times 5 raised to the power of 1, well, it's 2 times 5, which is 10. So when I have x is 1, we have 10. That's going to be way up here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right away, some of you are looking like this graph's not going to work very well because look at how fast we're moving up. So here's what I'm going to do instead. For this one, I'm going to count by 100s. Okay? And if I count by 100s, it's going to make life a little bit easier and make the graph look a little bit, because with exponential functions, you'll notice that we're going to have to skip around a little bit because they increase so quickly. So that 2 basically is going to look like it's at 0 even though it's not. Now when I'm at 10, it's also going to look like it's at 0, but it's not. We're just going to show a slight increase. Okay, we don't even need to show that slight increase. 2 times 5 raised to the power of 2. That's 2 times 25, which is 50. Now we're getting somewhere. Now we should be at the halfway point. 2 times 5 raised to the power of 3. Well, 5 raised to the power of 3 is 125. So now I'm at 150. Okay. I'm sorry, 200. I'm like, something's not right here. 250. So now we're at 1, 2, 3. We're at 250. So now we're going up. And then for 4, I have 5 raised to the power of 4. That's 125 times 5. I believe it is going to be 625. 625 times 2 is going to give me 1,250. So we're going to be way up there. So there's my function. Domain is all real numbers. All the x values work here. Okay, I could go negatives if I wanted to, and this is going to get closer and closer to 0, but it's never going to touch it. My asymptote is y equals 0. It's never going to get to 0. It's never going to cross that barrier. My y-intercept is 2, and my range is y is greater than 0. Because my asymptote is y equals 0, that means everything has to be greater than 0. And I am done. Okay, I think this is the last one. Let me double check. Yeah, this is the last one. So make sure you try it. See how you do. It is a fraction. That should be okay. And do your best. And I'll check your answers when you're done. Okay. Y-intercept right away we should know is 1. Okay. The y-intercept is definitely 1. There's nothing there. So it's really like times 1 here. So I know right away when I have my x value is 0, my y value is 1. Now my x value is 1. When I plug in 1/2 raised to the power of x, that's going to give me 1/2. So my x is 1, I'm at 1/2. My x is 2, I'm going to be at 1/4. Because again, 1/2 raised to the power of 2, which is 1/2 times 1/2, which is 1/4. When my x value is 3, well, notice we're just doing really 2 to the 3rd power, which is 1/8. So it's going to get even closer to 0. Now let's just plug in -1 to see what happens here. If I have 1/2 raised to the negative first, okay, well, negative means that we flip it, right? So that's really 2 to the positive 1, which is 2. So -1 means I'm at 2. If I had 1/2 to the -2, I'd flip it, so that's 2 squared, which is 4. So -2, 1, 2, 3, 4. So 1/2 is really just 2 to the power of x, but now we're backwards. Okay, and so my function, this is not gonna go well, folks. I can tell you that right now. There's my exponential function, and it should never actually hit 0 like mine did, because that says I can't draw right now. It should never hit 0 because 0 is my asymptote. So my asymptote's at y equals 0. My y-intercept was 1. That means my range, so my asymptote is at 0. My range has to be above 0. And my domain goes on forever with all real numbers. That's it. There's nothing else to it. Okay, so make sure you can identify all these key features of it. You should be able to write an exponential function by looking at a table or a graph, and you should be able to graph it as well. Also, what do you call a number that can't keep still? What do you call a number that can't keep still? A Roman numeral. It's just roaming around. That's all I got for you. Gordias out.